how does the physical infrastructure around quantum computing change? Like when you reach a certain scale, like what, especially on the satellite and space world, how does that change the physical infrastructure? And again, we can do a whole hour on this, but
of course. But the infrastructure component that we're talking about is the ability to interconnect either quantum computers, right, or quantum sensors across a quantum-enabled network, or the exchange of photons. And so what we're going to see, I believe, first is the ability to interconnect quantum sensors across an optical network and use that infrastructure for traditional capabilities. And then moving beyond that, we're going to start seeing quantum sensors that can be deployed into the environment of space, and like an RF sensor, as an example, or a navigation sensor. Some of those are being put on orbit today, and we're seeing some results that are very promising there. Again, with investment, right, and an increased cycle time for maturity of those technologies, that's where I think those changes are going to occur most quickly. And then between quantum computers, when you can interconnect, and the challenge right now is speed, but when you can interconnect two quantum computers and start creating a quantum cluster of computers, what you can do from a processing standpoint starts to become much more interesting. But right, there's work to be done relative to those quantum networks. And right now there's a number of different technical approaches to how you might interconnect quantum computers. But those are the areas of research that are starting to move into operational capability. And we are right now at that transformation, or that tipping point of what's research and what is operationally relevant, and then eventually what is going to become common infrastructure.
So a lot of the things have to change. You can't take two quantum computers and connect them with an internet connection and make a bigger quantum computer. It doesn't work that way. You've got to connect them with a quantum computer. Apple found out that when you build a chip, if you put the memory so close to the CPU that it's not actually communicating, it's actually the communication is such a big thing that putting the two on the same chip had a huge win for the M processors versus having a bus. Okay, and we're learning all these things about how distributed systems are, even inside your computer box, it's a distributed system. All of the things that we know how to do today, all of the laser comm, all of the RF comm, everything that we have has in it something that mucks up quantum in such a way that you can't just use the off-the-shelf stuff that we have today for quantum anything. You have to rebuild it. You can put a mirror in there, but a lens, not so much. Not necessarily. Depends on the lens. Filters. Everything you do, remember, everything's on a knife edge. And if you touch it the wrong way, it will make it turn back into classical and remove all that magic that you wanted to maintain. So we're going to have to figure out how to put quantum storage, quantum relays, quantum entanglement swapping, purification steps, which are a way of taking a bunch of quantum entanglements at low fidelity, low quality, and turning them back into one at high quality. So you're consuming the system. This is quantum networking. We don't know how to do it. We're just right now at the stage of where the internet was when people realized that, a single transistor could work better than a relay or a tube, right? But we're not at the point where everybody can do AOL at home, right? We're in that in-between phase where it's sort of like, we can see it coming. But, and I want to caution, we saw bubble memories coming. We saw Josephson Johnson's coming. There are things we saw coming. We thought were going to change the world that never panned out. We don't know. We don't know if this is going to work or not going to work. We don't know the amount of money people are putting into it. We don't know. We think it might. We hope it might, but we don't. We really just don't know. And so right now, I don't know what's going to change the future.